So just like how we had charges which are plus and minus, in terms of magnets, you have poles. Similar to how you had positive charge and negative charge, here you have so-called North Pole and South Pole. What do we mean by that? We will see that in a moment. But the beauty or one unique aspect of magnets is that, unlike electric case, is that in electric case, the plus charge and the minus charge can be separated out. That means you can remove the electrons from a medium, it becomes plus charge. You feed in more electrons to the medium, it becomes negative charge. Whereas in magnets, you can't separate out the north and the south poles. If you go ahead and break this magnetic bar into two, then what you end up getting is a new south pole and a north pole, south pole and a north pole. So they always exist as dipoles. Di means two, yeah. Just like electric field case, like poles repel each other, unlike poles attract each other. That means north and south, they get attracted to each other, whereas south and south pole, they will get repelling. They won't stick to each other. So what do we mean by north and what do we mean by south? So what it really means is that in the magnetic line field lines, if the field lines, which are essentially force fields, right? The force, direction of force that you tend to draw around, that gives you the magnetic field line. So it always starts from the north and goes to the south. So the direction of the arrow is from the north to the south. That's the convention. So you define this to be the north and you define this to be the south. But what happens inside the magnet? Inside the magnet, it goes from the south to the north. Yeah. So they make a closed loop. So outside the magnet, it is from north to south, and inside the magnet, it goes from south to north. So they complete a loop. Yeah. So they are always forming closed loops. That's very important. Later, we will see mathematically how that translates to, in what kind of mathematical expression that translates to. So how do we know these are the lines of force? You take a compass, magnetic compass, you place it around a bar magnet. You see that it indicates that this guy is the north. So all of it is going to be aligned so that you see that the north gets attracted to the south. In the compass, the north of the needle gets attracted to the south. Just like how we had the electric field intensity, which is E, the electric field intensity, which is E, and having the units of volts per meter. This is a force field, force experienced per unit positive charge. The magnetic intensity is going to have the units of amperes per meter. So in one case, it's the voltage. In the other case, it's the current. So you kind of get the analogy between them. Now, one interesting fact is Earth itself is a big magnet. Magnetic south pole of the Earth, the magnetic south pole of the Earth is in the geographic North Pole, and the magnetic North Pole of the Earth is in the geographic South Pole. Yeah, so the polarity is flipped, and that's why when you have a compass, the compass needle, the magnet inside the compass has a North Pole and the South Pole. The North Pole shows the geographic North Pole because it is attracted to the magnetic South Pole. Yeah. What are the sources of magnetic field? So magnetic field, there are three different sources. One is permanent magnets. Yeah, which is very obvious. Yeah, this magnet is permanent. Yeah, there's a magnetic field around it. It's made up of magnetite. The other possibility is you can have simply a direct current. A current is already a source of magnetic field. If I have a wire which carries a current, it becomes a source of magnetic field. And that kind of magnet is called as electromagnet. So permanent magnet is one kind. The second kind is electromagnet. And electromagnet is pretty cool, right? Whenever you don't want the magnetic field, you just turn off the current. When you want the magnetic field, you just turn on the current. So you have the control of when to have the magnetic field and not. Not only that, you can also change the polarity of the magnet. That means if I want to have north pole on the top and south pole in the bottom, I wind the coil in a particular manner. And then I inject a positive current. This becomes north, my thumb becomes the south. If I inject the current in the opposite direction, this becomes the south and this becomes the north. So I can flip the polarity. And that's pretty useful in motors, for example. That's used in the motors. The only disadvantage with electromagnets is that you need to feed them with current. Huh? So you need a battery or something, yeah, to generate that current. But then you have all these advantages of controlling the magnetic field as you want it to be. Then comes the last part where we can create a magnetic field that is changing with time by simply having an electric field that is changing with time. A changing electric field will cause a magnetic field, which is the interplay of electric field and magnetic field together. Yeah, that leads into a new science called as electromagnetics, coupling of electric and magnetic together.